Ooh, there's my awful face. I'm going to send you all this link, and you can just log into this link. Try this link. Yeah, I think the college, they had problems like this last time, and the college killed everyone's webcams. So so try that. See if you can't get into Zoom. My screen is showing, although boy, it's like upside down. Oh, what is? And does it? It's not blurry. You all are saying. I think we. Go ahead. Hey, yay! Save me a minute. Good. Go ahead, T. What you got?
Wait, what? I didn't say anything.
Oh, okay. Sorry, I just saw your thing go unmuted. Okay, so let's now that we're in here, let's try. So you can still chat, by the way. You can send me chat messages. I think it's good that we all just leave our videos off, just so it doesn't slow things down. But you can certainly turn yours on if you want to like show your face for a second, and we can all say hi. How nice to be in our PJs, kind of thing. How is everyone okay with this? State the confidence interval. We got it from here, our point estimate, the center of that is the X bar, and then this is how we would interpret this confidence interval.
Is all of this, are you videotaping this? Because I missed this part because of the thing. I don't know.
So the first, the first part that we did in Big Blue Button is saved and videoed, and then this is being videoed, and I'll upload this to JetNet as well.
Okay.
And then of course there's always Alana's videos where she went over all this as well. Okay, so the next page asks us to find a few things. It says, well, what's the point estimate? Of course, we know that's the X bar that's equal to 72 cubic meters. And that's the center of the interval. Recall that if we wanted to calculate the point estimate, like if we knew the confidence interval, we would add the upper and lower limits together and divide by 2, and that would get us the center. And then the margin of error was that 10.816. And another way we could calculate that is take the width, which is the distance between these two. So it was this one, and divide it by 2, and we would get the width. Whereas that, it's the distance from either limit to the center or point estimate. Okay, so now things get a little crazy. For the proportions, we used z-scores, critical z values. Recall they look like this, z alpha. And then for CIs, because we needed the upper and lower bound, we found z alpha divided by 2. And it was plus or minus that, right? Well, for means, we have to use a totally different distribution. It's called the T distribution. So this is not the Z curve. So it's not these. It is a T alpha. We call that a T critical value. And then for CIs, confidence intervals, we're going to use a plus or minus T alpha divided by 2. So what's up with this T distribution or this T curve? It is very similar to the Z curve, but it has a shorter peak. So each one of these are T curves, this peak, this peak, this peak. And the very last one is the Z curve. So it has a shorter peak and fatter tails. You can see that these tails, this tail here is the fattest of them all. And then we have this thing called degrees of freedom. And so there's infinitely many different T curves. And when we get infinite degrees of freedom, this corresponds to the Z curve. Now, here's the truth. You don't actually have to know all of this. You just have to be able to calculate critical T values. So you need to know, how do we find the degrees of freedom? Well, it's the sample size minus 1. That's the degrees of freedom. That's it. A very simple calculation. We're going to use DF to stand for degrees of freedom. Note that these T distributions are symmetric about the mean equals 0. Just like everything else, this is a probability distribution. So the area under the curve is 1. Half of the area is above the curve, half is below. It has that horizontal asymptote of the x-axis, meaning there's area forever outside it. It's a little more spread out than the Z distribution. And then as we increase the sample size, which we denote with N, the curve, this T curve, gets closer to the Z distribution. So skip a couple pages. We're going to skip all the way to the critical T values, this picture. I'll pause and make sure you all get there. How many people did we lose? A lot.
I'm just saying, this already is working a lot better than Big Blue Button, or whatever it was.
Good, good, good. Well, we'll just use this forever on then.
Yeah, that sounds good.
So Eric, how do you, like if I want to, oh yeah. So how did you just do share screen?
For what
To
I'm
show
doing
your
right now?
Yes, to show your doc cam.
Down under the video thing, there's a little up arrow, and it allowed me to select the IPEVO thing. That's where I did it. So I didn't do share screen.
Okay.
So I just changed the camera that was being used.
I love this.
Isn't this fun?
It is. I'm on a beach.
Oh yeah, you can change the backgrounds. That's right. That's right.
The virtual background. That's great.
I wish I was there.
Here, I'll send you the picture file, Cindy, and then you can do it.
Yeah.
There you are. Yeah, there's like, you can change your back. See, Chandler's background has got this. Yeah, that's wonderful.
Yeah, and I don't even have my green screen set up and it works, which is cool.
Okay, so let's do these critical T values. Note, it's really hard to see, but this is a T alpha. So later we're going to work with T alphas. We always calculate these degrees of freedom as n minus 1. And then often when we do the notation, we don't do T alpha, we do T alpha and then put the number for the degrees of freedom. Just like with the Z curves, this area, go ahead. Oh, hi, sweetheart. That's a right tail area. So if we wanted, say, this left tail area, if we wanted to find this, we would have to do 1 minus alpha in our calculator. Actually, if we want to find this, we would have to put in 1 minus alpha here to calculate it. So maybe ignore that. So down here, we got this half alpha. This is what we're actually going to be doing cutting alpha in half and then calculating the area on either end. Yay, Layla, you made it. Good. Both Laylas. So how are we going to find these?
Here.
It's this thing.
No. No.
So let's do 3 problems. Unless y'all have some questions.
So Layla, you can mute your mic in the left-hand corner. There's a mute
Oh,
button.
I did not know that.
That's okay. I know
I
this is
didn't
new.
know.
That's okay. You can mute it down in the left-hand corner.
We don't mind crying babies. All right, so this is the exact same thing from, exact same page from 9.1. There we did all Z critical values. Here we're doing all T values. And it's just how we get it in the calculator. So do your usual stuff. Use your English skills to note that this is a plural word, meaning 2 critical T values. So we need to find T alpha divided by 2 comma DF, degrees of freedom. So to find alpha, we note that the sea level is this. So alpha is 1 minus that sea level. And then the degrees of freedom is always 1 minus n, sorry, n minus 1. So in this case, that would be 17 minus 1, which is 16. So what we are going to try to find is plus or minus T of, oh boy, we need half alpha. So let me show that over here.
Eric,
Talk to me.
what's that T over there? My glasses are broken and I can't
Let me write it bigger.
broke them. I can't see nothing.
I feel your pain. Just before the day they started closing everything down in Michigan, I got 2 new pairs of glasses. So my broken glasses are finally fixed.
Oh gosh.
No more tape.
Thank you.
You're welcome. Okay, so we know that the number for half alpha is 0.05. Sorry, 0.025. Our degrees of freedom are 16. So what we're going to do is plug this into a new function in the calculator we've never used. It's called inverse T, and it's going to ask us for the area and the degrees of freedom. That's it. So here's your calculator. You're going to go to second VARS to open the distribution menu, and you're going to choose option 4, the one that says inverse T. Note it asks for area and DF. So the area is the 0.025. This is going to give us this lower tail value, so it's going to give us the negative critical T value. And then the degrees of freedom are the 16 that we had. Paste that in. Takes a little bit because it has to think to calculate it. And I'm getting approximately plus or minus 2.11. Oh boy. Since we need 3 decimal places, note the 9 after this 9. So when I add 1 to 9, it becomes 10. So this is really plus or minus 2.120. So 2 point here, this corresponds to a 0.025 area. Shoop, 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 shoop. And then over here, our negative 2.120 corresponds to this area. And just as before, our center value here is 0, just like a Z-curve. Has the same mean. The standard deviation is different. We just don't know what it is. Questions? Okay, let's do another one. So again, we'll use our English skills to note plural, meaning 2. Here they give us alpha right off the bat. So we're going to cut alpha in half. And then they give us a sample size of 35, so our degrees of freedom are equal to 35 minus 1, which is 34. Note it says what confidence level would we use? We'll recall that the C level is the complement of alpha, so that's equal to 1 minus alpha. In this case, that's 0.995, or 99.5%. Okay, we have everything we need. So if I'm drawing, I would probably try to show less area than the problem above, and this would be 0.0025. If I was grading a hand-drawn graph, I would not be particularly picky about how you draw it. And then I'm going to write down that we're going to find this plus or minus t alpha cut in half, comma, degrees of freedom. I didn't intend to write the symbols. So here's the number, 0.0025, comma, 34. And that's going to be equal to the inverse t. That's the calculator function we're going to use with this area and this degrees of freedom. So one more time in the calculator. Second variables, option 4. Our degrees of freedom are 0.0025, sorry, our area, and then the degrees of freedom are 34. Paste away, calculator thinks for a second, bam, there it is. I need 3 decimal places, so because of this 9, I'm going to add to the 1, and this is plus or minus 3.002. And of course, again, the center of this is 0. Okay. Not crazy difficult, right? It's just now you have 2 things you have to remember: inverse t for z critical, for t critical, and inverse norm for z critical. All right, last one. So now we're going to find the critical t value. Note this is singular. So we just need one critical value, and we have to figure out which one it is. They said that would cut off the top. Every example we've done is the top, right? So the top 5%. Now the key to note here is that that is the half alpha already. So if I were to draw the area down here, it would also be 0.05. So I'm going to write alpha divided by 2 equals 0.05. That means alpha itself is equal to 0.1, which means that our C level, which is 1 minus alpha, is 0.9, which we could write as a 90% confidence level if we wanted to stick with that. Notice the degrees of freedom have been given to us. If I wanted to state the sample size, it's just add 1 to the degrees of freedom. So our sample here had 21 whatevers in it, 21 people or 21 scores or whatever it was. Okay, so here's what we're going to do. We're going to calculate just the positive t critical value. Its half alpha is 0.05. Its degrees of freedom is what they handed to us, 20. Now, if I want my calculator to spit out the positive value, I'm going to have to type in 1 minus 0.05 to get the actual left tail area. I think there was 1 or 2 of you all in the class that had the color calculator. That one you could input that it's a right tail area. Oh, Zoom is going to keep going. Thank you, Zoom. Okay, so notice this option 3 inverse norm, that's for z critical values. For 4, that's inverse t, that's our t critical values, that's the one we want for this problem. We're going to put in 1 minus 0.05 and our degrees of freedom of 20. And
I have a question.
please.
So how do you know when you use 1 minus?
Great
Is
question.
it just when you do the top?
Yes, but you don't even have to, because look what happens if I don't use 1 minus. Calculator just gives you the negative, right? So as long as you look at your graph and say, oh, I know this had to be positive, it just gave me this value, you would just change that to a positive.
You can just make it positive. Okay.
That's it. So either way, I'm not picky about how you do it and how you write it down. So final answer here is 1.725. That's the only new thing in this section, because everything else is just finding the confidence interval. So other questions? T, thank you for asking that question. Y'all, please chime in. I'm talking to a bunch of Lego bricks over here, is what it feels like. Like everyone loves this Lego horse, man. That's worth some money right there. That's good Lego.
Oh, that's the old stuff too, ain't
Yeah.
it? The good stuff.
That's right.
Nice. The
I
old
just sold
kingdoms.
this. I sold this horse that goes with a castle for $120. Someone bought it. It's crazy.
Oh wait, the old castle, like which one?
The Bat Lord's Castle.
I'm
I'm
trying
kind
to
of sad
think.
I sold it, but
Hey, $120 is $120.
that's right.
Like, I mean, you can't be too upset with that for a Lego set, you know.
Yeah, I can buy like 20 pounds of Lego and maybe turn that into another $200. Who knows?
Exactly.
Okay, so here's the new formula. You don't really need to know this, although you are going to have to write it down if you take paper things. So on the exam 3 pre-due, one of the questions will say, show the formula, the substitution, and the results. You'll write this down on that. Here, you're being told what the point estimate is, x bar, before it was p hat. And these are the 3 conditions from the central limit theorem for means. So notice that last one is the only one that's different. You have to have a sample size of 30 or a normal distribution. So I'm going to show you how to do all this in the calculator. Here goes. What? Here's data. So let me go back to the formula real quick. We need a sample mean and a sample standard deviation and a sample size. Those are the 3 things we need. So this set of data is robbery and property crimes published by the FBI. It's in dollar amount. I feel bad for this person. This person's probably fine. It's funny that they reported it. So how are we going to get an X bar and an S and an N from this? Dun, 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 dun. Dun, 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 dun. Right here, you're going to put in the data in your calculator. So this isn't grouped data, so it's going to go only in one line. So you'll just put all these in. Doesn't matter how you enter them. You can go like column or you can go row, whatever you want. I think I'm going to do column. So I don't know if you realized I'm racing you. So I hope I win because I got a head start. Yeah, but I made a mistake.
Are we putting them all in L1?
Everything in L1. Yep, it's not group data. It's just, this is all the data values. Yeah.
Okay, gotcha.
Now I see that I have 25 data values in my calculator. If I look at this, there's 1, 2, 3, 4, 5 in a column and 1, 2, 3, 4, 5. So 5 times 5 means our sample size should be 25. So I at least have the correct amount of numbers in here. Let's see if we all get the same mean and standard deviation. So you go back to stat, we're back to an exam 1 material, right? Calculate 1 variable stats. And I put mine in L1. This is not a grouped data set, so we leave frequency list blank and we run the calculation. I've got 513.32 as my mean, and my sample standard deviation is 262.23. Anyone have something different?
I'm still putting them in. Oh,
Okay.
you right.
Well, don't say that. I'm probably wrong. I screwed these up every time in class, it felt like. Okay, so if that's true, then what is the point estimate for the average loss? So recall what the point estimate is. That is the statistic. And the statistic we're interested in here is average. So in this case, it's X bar. So our point estimate is 513.32. Explain the statistic from the sample is always the point estimate. Always, always, always. By the way, if anyone chimes in and sees that I have a mistake in here, let me know and we'll go back and try to fix it. All right, so now we're supposed to see, can we actually construct this confidence interval? In other words, have the three conditions from the CLT been met? So recall condition one, we need randomness. Well, that's given. It's always given. We always assume it's randomly taken. And in case you're wondering, it says it right here, simple random sample. Condition two is our sample size larger than the population, or was the samples taken without or with replacement? So it doesn't say that this sample was taken with replacement. So we have to check, is the sample size, so is N less than or equal to 2.05 times capital N? Well, our N is the 25 pickpocket losses, and then our capital N is all pickpocket losses. And here I have no clue how many pickpocket losses there are out there. And we should be clear here, since this is data from the FBI, these are robberies that were reported to the FBI, not just robberies. We're going to assume this is true. I don't know. We could look it up, but it's probably true. There's probably like, I don't know, what do we need to get to? 1,000? Whoops. Yeah, if we had 1,000 losses, then this would be fine. And I'm sure 1,000 people got robbed back in whatever this year was that they did this. So we'll just assume that's true. And the final condition is normal. Now recall, to be normal, either the population itself had to be normal or our sample size had to be 30 or greater. Notice our sample size is not large enough to guarantee a normal distribution for the statistic. So this is sitting here, and this is a normal probability plot. So if you recall from exam 2, because this is here, we would say yes, because the normal probability plot is approximately linear. That means all of these points are pretty closely clustered around that line. The R value here, the correlation coefficient, is probably like a 0.9 something. All right, so we can construct a confidence interval for this mess, and we can try to predict the mean amount of money stolen for all reported pickpocket losses. Right, I just noted it. I should have said reported. That's pretty important. Okay, let's do it. So this says, construct a 95% confidence interval for the average of all reported pickpocket losses in dollars. Show the formula, substitution, and the answer. All right, so here comes the formula. I'm just copying it down from page 216. It's X bar plus or minus the T alpha divided by 2 times the sample standard deviation divided by the square root of the sample size. So we need to list these 1, 2, 3, 4 things. X bar, S, N, and then T alpha divided by 2, comma, degrees of freedom. I'll add that in here. So X bar we knew from the previous page from our data set, 513.32. S, which is the sample standard deviation, we also knew from the previous page, 262.23. N we knew was our 25, so all we have to do is calculate this mess. Notice alpha is equal to 1 minus 0.95, so it's 0.05. Half of that is 0.025. And then note that our degrees of freedom are 25 minus 1, which is equal to 24. So this actual value that we're going to find is going to be T 0.025, because that's half of this, comma, 24. So you don't have to write this at this point, how we found the critical T value. I'm going to remind you how to find it. It's inverse T, comma, the area, comma, the degrees of freedom, and that's going to give us an approximate value, and we want plus or minus that. Note this plus or minus matches the value up here. So let me show you again how to find that in your calculator. You're going to hit second distribution, option 4, 0.025, degrees of freedom are 24. I am getting plus or minus 2.064. So the last thing we need to do is use our calculator to actually figure out what this formula is. Please understand, you all, we are not asking you to plug these numbers in here and then use your calculator to perform this calculation. We want you to use the entry in the calculator, the formula in the calculator to calculate it. So that where you find that is you hit stat and you choose tests, and we go down to the T interval. Now, there are 2 ways to calculate this. We could use statistics. That's these numbers we wrote down. We could type them in. Note they're already preloaded in here, and I'll tell you why in a second. Or we could use data and tell our calculator what data should we use. If you recall, I put mine in L1, and that's where the data was. So since I have the data entered in L1, I'm just going to use the data to run this. If you didn't have data and they just told you a sample mean and a sample standard deviation and a sample size, you would plug it in the stats place. So I scroll down and I hit calculate, and there it is, 405.08, 621.56. That is our confidence interval.
Can you go back over that in the calculator again?
Most definitely.
Yeah, why was there a 1 in the frequency list? Was that needed?
Yes, always leave that as 1 because we don't, it's not a grouped frequency.
Gotcha.
So you hit stat again, you go to tests, and it's the T interval, so it's option 8. And then you've got data, you have to, wherever you put the data, you select that. So I did second 1 to pick L1. And then frequency is always going to be 1 with this. So you'll just leave that. Then your input, whatever your confidence level was. I think I forgot to highlight that up above. We're told the confidence level back in the problem. That was 0.95. Notice because we ran the stats, because we ran one variable stats, these things were preloaded, which matches these guys over here. So using the stats gets you the exact same answer. Now, if you typed in 262.23, you might get a slightly different answer here because you rounded that sample standard deviation. How are we doing? So let me forget to talk about homework and share my screen so we can see what you all should be doing and all that mess. Okay. Well, let's interpret this 95% confidence interval. So we would say we are 95% confident that the population mean, and what was this? The population mean reported pickpocket offenses was within this interval. Note that the units on these things are dollar amount. So we're saying of all the people that got robbed in a pickpocket manner, I suppose, or I'm not quite sure how the FBI defines pickpocket losses, but of all the reported robberies, the amount of things stolen, the value of it, either cash or items, was 405.08, somewhere between that and 621.56. Okay, so this local law enforcement agent states that the amount of money for pickpocket offenses locally, so we'll stick with Jackson. So our sheriff's department at Jackson says, hey, the amount of money that's stolen in Jackson, the average amount is lower than the national average. And then they're like, it's 420. So if this is correct, so if this 420 is the actual average amount of money stolen in Jackson, does our confidence interval support our local law enforcement's claim? And we're explaining using the confidence interval. Well, first note that 420 is within the interval. And we claimed that our local amount stolen is less than the population amount. So we're going to say no, because 420 is within the confidence interval, which means that the national amount stolen could actually be lower than this. Like, it's possible that the national average is 405. It could also be true that the national average is larger. It could be around 600. We don't know. We just know it's somewhere in between here. So our confidence interval does not support this claim of lower because the 420 is within it. Now, if the 420 had actually been below the lower limit, then we would have been able to say yes, because 420 is below the lower limit. Does that seem good, y'all?
Makes sense so far.
Good. Good. Okay, so this one, this is a little bit of old course pack, right? There have been 45 presidents of the United States. Let's just pretend including our current president wouldn't change the mean height of the presidents. So why are we not going to construct a confidence interval? And the answer is this 70.73 is the population height. So we do not construct confidence intervals when we have parameters. And this is an example of a population that's relatively small. You know, there's only 45 presidents that we have to work with. If we wanted to know, say, the height of all males in America, that's a very difficult thing to measure because there's millions of males in America. So measuring all their heights is impossible. But with the heights of the presidents, my goodness, we get all that stats. Don't they have to like show us their health records and all that mess to prove that they can actually do their job health-wise and all that stuff? So we know all kinds of data about presidents. So this was a pretty easy calculation to do. Well, y'all, that's it. That is section 9.2.
Can you explain just what you just did? Why? Like, because it's a parameter, because there's a small population of presidents, or what?
Yes.
Okay.
We have the exact height of the exact average height of all presidents. In other words, this is a parameter, and we construct confidence intervals to make a guess at what the parameter is because it's too difficult to actually measure the population. So maybe that's a better thing to say here. We measured the population. In other words, we can say we're 100% confident that this is the true parameter because we calculated it from a population. That's the key. When we calculate things from populations, we know the parameters. So there's nothing to infer. Is that helpful?
Yeah, thank you.
Good. Good. I every time I hear little background noises from you all, I think, I wonder what your families think as they listen to this exciting discussion of statistics. Okay. So let me share my screen, and what I want to show you is the homework. So let's see if this is much better than. Can you all see my screen?
I can.
Yes.
Yeah.
Wow, that
Yes.
was like super fast. Okay, so no more big blue button ever. Sorry, big blue button. Okay, so here's the homework. What is due tonight is 8-1 and 8-2, 3:30 at midnight. And 9-1, sorry, those three. What we just covered today is 9-2. What we're going to cover on Wednesday is 9-4 and 9-5. This lecture video is Alana's lecture of 9-5. You just have to open it and close it. It's good to watch it, but you don't have to. So we will finish chapter 9 this week. You'll have a chapter 9 quiz due. So check what I do here. I scroll back up under homework. I'm now changing to quizzes and tests. And you have this chapter 8 quiz that's currently due tonight at midnight. I'm definitely going to extend these things from what happened this weekend. You have 4 attempts on the quiz. And then the chapter 9 quiz is going to be due next Monday because we'll have finished it this week. The reason
So chapter 8 is a graded quiz, correct?
It's a graded quiz, yes.
Okay.
And the reason I'm doing that is because I want you to practice the higher stakes testing type thing, because in here, I'm eventually going to add in the chapter 3 or the exam 3 quiz, which is a combination of these, exam. It's a combination of these 3 quizzes. So I want you to experience what it's like to have to figure out how to get it right. You might only have 2 attempts for that exam. It will be timed. So once you sit down, you have to finish it once you start it. And then I'll give you like probably 2.5 hours to complete it. That's a way for me to try to test that you're doing this yourself. You're not calling all your friends and getting answers or whatever. So that's the point of the quizzes. I don't think these things are crazy long. Yeah, this is 13 questions. So it's a little longer than some of your homework. Here's a true or false one. Notice it doesn't give you feedback once you've answered it. You can jump all the way through it. And then once you're done, let's see, does it give me an option? Where's the submit thing? Oh yeah, it's hidden. Then there's a submit quiz.
Hey, Eric.
Talk to me.
We still see the other screen.
Oh, you can't see. That's right. Okay,
Yeah.
let me change that.
Yeah, if you change it to like screen 1 or whatever it says, you should be good. But
Where's my? Okay, we'll just do that. No, I don't want to end the movie. We're having too much fun. Oh, keep clicking the wrong button. Here we go. Okay, so you would be here. Thank you, Chandler, for. You can answer these questions. Notice a bunch of these are multiple choice, and then there's some. Here's another one. There we go. There's some things where you have to fill in. And then once you've answered all that, you would submit the quiz, and then you're going to see your score. Wow, I failed. And it looks like it's even going to let you look at what you got wrong. So you have 4 attempts on those. And then the homework, oh, I wanted to show that just to make sure everyone's doing okay on the homework. On the homework, you have to be in this screen, the homework tab, in order to adjust your score. So you would just select it. If you had done all the problems, if you see any X's, you'd go click that one you got wrong, and then you'd get
we're seeing your
Oh,
webcam.
yes, I'm sorry. Thank you. Where do I want to show? Not my email. Here we go. So you would go, you have to be on this homework tab in order to change your score in the homework. So you would go to the homework assignment, click it, and it opens in this screen. And any place you have an X, that's the one you have to retry to get correct. There is a 10% deduction from your final score if you do it after the due date, which just this once, I'm going to extend the due date because of what happened this weekend. So I'm going to put it, let's see, it was 3 days that it was down. No, it was down 2 days. So I'm going to extend it 2 days for you all to account for the 2 days of time you missed. Which I understand is probably not the same thing since it was weekend and you might not have happened to be working over the weekend. But
Thank
I
you.
want you to.
I needed that. Thank you so much.
Yeah, you're welcome. I need to do the same thing for the quizzes, and the quizzes, I'm going to extend this quiz all the way to next Monday.
Thank you.
Okay. So what other questions do you all have or things you need from me?
So we're only doing 9.2 today. We're not doing 9.4 also?
Correct. 9.4 and 9.5 we're going to talk about on Wednesday.
That's because they're shorter?
Yeah, kind of. Also, we just did a ton of stuff. I mean, I could start 9.4 if y'all want me to.
Eric, 10.1 you have in my stat lab to be due next Monday.
Oops.
So you might want to check on that.
Yep, that needs to be
No,
changed.
I'm not saying let's rush into it. I just want to know if we were just doing 9.4.
Okay, no worries. Yeah. We're not going to start that till Well, I'm not going to cover it till Wednesday. I would encourage you, I don't know if you all are watching the online videos, you're welcome to do that. I encourage you to check those out if you wanted to beforehand.
Yeah, I'm watching them. My brain is a fog, but yep, I'm watching them.
Well, and I got 10-1 due the 13th.
Oh, I must have.
Let me double check the quizzes. Yeah. I think it's okay. Maybe it's maybe I had it there at one point.
Okay, good.
I hope you all are, your mental health is good. I know these are very trying times. This weekend I was kind of struggling with things, so I hope, I think this is probably helpful for your mental health. It's a good distraction. It's a challenge. We want you to be able to complete and get a grade, and that's what you're working on now. So I'm glad that you all are showing up. Keep working. Let Cindy or I know what you need for this class. And then, like, if you have food insecurity or housing insecurity, feel free to let us know, and we can try to connect you with resources. The college does have
Hey,
some
Eric.
resources. Go ahead.
Okay, so this class is pretty okay, but like us, like in chemistry and like other people, we did like we're doing a petition to see if, like the other schools, if we can just get like a credit or no credit instead of a grade, like in some of the other classes, because this class is not as difficult online as the other ones.
I have
So
no
I
idea how
don't
those
know.
lab classes go. Yes.
Yeah, it's terrible. Like, I don't know. So I don't know. I don't have nobody's email or nothing like that. It's nothing. I'm not trying to shortcut a grade or nothing like that. But some people do have like issues with being online. So like we
Yes.
did that petition. So hopefully other people will see it and sign it. Cause like trying to do labs for chemistry and other sciences, that's hard online.
Well, the
I
entire
tell you
nursing.
what.
Oh, go ahead, Chandler.
Oh, my psychology class is horrible.
Yeah.
It's like I could be. It's not online. Well, it's not like a virtual class like this. It's just like read the book and then answer
Mine
questions. And
either. Yes.
Yeah, that's how
I
my
Yes.
cannot
business
learn like
classes.
that. I
Yes.
cannot
That's
learn
how
like
my
that.
chemistry
And
class is. Exactly. He's not going through like you're doing, Eric. Oh my God. He's not doing that. He's just going through just reading stuff, and like we're like completely lost. Like, I don't know.
Yeah.
see what you're doing, Eric and Cindy, is like
We
1,000
appreciate
times
y'all.
better.
I
Well,
swear.
good.
for
We're
real.
Yes.
glad we're doing good stuff for you.
And we've been like, I've been giving him pointers because he didn't even know, oh my God, he didn't even know how to like record the sessions or anything. And I was like, well, my teacher, Eric, I know he's tired of me saying that, but I'm like, well, my teacher, Eric, is going online and he's recording them and he's putting them into different, like my stat lab or something like that, or you can do it on YouTube. So now he took my advice and now he's doing it like the recordings on YouTube, because he had no idea. Like, when we first logged on with him, he was like totally lost. Like, I think that was his first time trying to log on or something. I don't know.
Well, it did catch everyone at the college. You know, I didn't sign up for online teaching, but we didn't have a choice, so
Right.
Right.
yeah, so it is difficult for everyone. And there are, like, you can talk to your navigator about, feeling like you can't pass a class, and there are options because you didn't sign up for an online class either.
Right.
So I would just start that conversation as soon as you can if you feel like it's not going to work for you.
Oh yeah, I have. We all have
Okay, good.
emailed the navigator and the dean because we wasn't getting it face to face, and now we got to do it online.
Right.
Right.
But anyway,
You
sorry.
guys, I have one question for you. When Eric sent that link, did you have to download Zoom on your computer in order?
Yes.
Okay.
Yes. Yes.
All right.
That only
I'm
took a
gonna
minute though.
Yeah, right. I'm gonna send a remind out. So for those of you or people that were not here, they could have Remind downloaded. So when we send the links from now on, everything will be going through Zoom instead of the U button.
Do you have to send a link? I'm pretty sure it's just like the same classroom code every day. I might be wrong though.
Well,
But yeah.
what do you think, Eric? I think we can set up sessions though.
Probably.
Yeah,
I'm
I
still
don't
gonna
know.
I'm still gonna email a link for everyone because I think it's for some
Right.
people I think it's just easier to get that and click it. But I think you're right, Chandler. It might just be
Yeah.
I think it does change. If we set up a particular session, I do believe the code does change. So you guys don't want to
Okay.
have that same code. It will change.
yeah, I think you're right too. Yeah.
Yes.
Unless we could set up the classroom to reoccur, but I don't know. Yeah. We'll send out emails and reminds and
Yeah, that works just as good.
I think since we started that, I think it's easier for people to look for that that link to click on. But obviously we just need to have Zoom. But I think this is much clearer. We don't have to worry about. Yeah, I think this is better.
Yep. Guess we
Yeah.
should have just listened to Mona in the first place.
That's okay.
And when we say we, I should have said me.
No problem.
So I am going to